as we look at lesson 3.4, part 2, synthetic division, every problem you did, well, no, maybe not every problem. Most of the problems you did Friday in homework could be done with synthetic division. Okay? I asked you to do them with long division, but most of them could also be done with synthetic division. Now, I will say, the catch about synthetic division only works if you're dividing by a linear binomial. In other words, where it's an x to the first is your highest term. So if we had something where we were dividing by x squared, we can't really work that with synthetic division. Okay? But this actually is the first problem from Friday's notes. This is the first problem from lesson 3.4, part 1. Friday we long divided it. Today we're going to synthetic divide it. And the nice part about synthetic division is basically we get to drop out all the variables and just use the numbers. Okay? So, when I set up my synthetic division, I set up a box there. That is what we are dividing by. Now, we're dropping out the variables, right? We're dividing by the factor x plus 5. Well, when it's given in that factor form, you want to use, I guess I would think of it as the 0, or in other words, if we are solving this. So if you had to solve x plus 5 equals 0, what would you get there? You would get negative 5. So negative 5 is the number that's going to go in our box that we're dividing by. From there, to the right of that box, we're going to list the numbers in our dividend. Now, we only want the coefficients. So starting with 4, it will be incredibly important that you don't have missing pieces. So if you start with an x squared term, after an x squared term has to come in x term. After an x term has to come a constant, right? If you have missing pieces, you have to get the zeros in there this time. Okay? So after 4 is going to be a positive 23, and after positive 23 is negative 16. Now, when I draw this line underneath, I left room to put a row of numbers in there, because we're going to have one row of numbers in between the top row and that line. Okay. First step is we're going to carry that 4 down to our answer. So I'm going to take this 4 right here, and I'm just going to carry it down, and it goes below the line, which is where my answer is going to be. From there, your next step is a multiplication step. We're always going to go back to our divisor here, which is negative 5, and we're going to multiply that number by whatever our most recent number in our answer is. So I'm going to take negative 5 times 4. What is negative 5 times 4? Negative 20. I'm going to bounce that negative 20 up and put it underneath the 23. Okay? Now, one difference. Long division, after you multiply, you usually subtract. Synthetic division, we add. So, add the column. What is 23 plus negative 20? 3. That is the next piece of our answer. Now we're going to repeat the process. Now we take the negative 5 out front, and we multiply it by our next piece of our answer. So we're going to take negative 5 times the 3. What is negative 5 times 3? Negative 15. Guess where the negative 15 is going? Up under the negative 16. And then what do you do with those two numbers? You add. What is negative 16 plus negative 15? Negative 31. 4, 3, and negative 31 represent our answer. We don't leave it as 4, 3, negative 31. We have to put the variables back in. Okay, but other than that, we're done. We just have to put our variables in. When we go to put our variables in, this is originally a 4x squared, correct? And we are dividing by an x to the first. What happens when you take an x squared term and you divide by x to the first? What is that exponent going to be now? X to the first, right? So the idea here is that in front of the, or after the 4 is going to be an x to the first. I don't like how I put that. I would prefer to have it, well, we'll squeeze it in. So right here we have 4x to the first. This is a positive 3, so plus 3. Well, what comes after an x to the first? Just the constant, right? What's that make my negative 31?
Remainder.
That's my remainder. So that last value there will always be my remainder. So my answer is 4x plus 3, remainder of negative 31. Do you remember how we wrote our answer on Friday if we had a remainder?
It's number over the divisor.
Yeah, number over the divisor. My divisor was x plus 5. So since this is minus 31, I'm going to say minus 31 over x plus 5. Sorry, that got a little squeezed in there, more than I wanted to. May seem confusing at first. However, once you get the hang of it, I promise you'll like it better than long division. That's scary, but thank you. Questions here? We need to try the next one and see how we're feeling about it.
Next one. Yeah.
I will say, I feel like you usually use synthetic division with the bigger examples. Okay? And by the way, if you take example A back to Friday's notes, it's the same answer. Okay? Yes?
That's what we're asking. It gives you the same answer as if you did.
Yep. Yep, you could have done A with long division. Well, we did do A with long division on Friday. Same exact answer. Okay? Yeah. Synthetic division is just a shortcut. Let's try B then. What's going to go in my box? If it's x minus 2 is what I'm dividing by, but I want to use the 0 representation. So set it equal to 0, and we're going to use 2, right? So in my box it's going to go 2. Okay. What about the row of coefficients that goes beside it? What's the first coefficient that goes beside it? In front of x cubed is a 1. Then I'm going to have negative 14, 51, and negative 54. Leave room for a row of numbers, right? And then put a line. Okay, first step is what? Drop down that first number.
Bring it down to
It's just a 1. And then we start our multiplying step, right? Multiply, add, multiply, add. So, the 2 in the box times the 1 down here. What is 2 times 1? 2. And where am I putting that 2? In that next open spot, which is under the negative 14. What do I do with negative 14 and 2?
you add.
We add. What is negative 14 plus 2? Negative 12. Repeat the process, and we are multiplying. So back to the 2, always with the 2. 2 times negative 12 is negative 24. That goes under my 51. 51 plus negative 24. 27. Is that the right math? And now what? Multiply. 2 times 27 is 54. What's negative 54 plus 54? 0. What does that 0 represent? Yeah. We have a remainder of 0 this time. Okay? Do you know how to express your answer? I mean, my pieces of my answer are 1, negative 12, and 27. 1x to what power?
The second.
Why the second?
Because remember, can't have x, so it has to be 1 the second, and 1 negative 12x and 27.
Okay. Okay, so you were looking at kind of counting down to figure out?
Yeah.
Okay, so multiple different ways to look at this. And I agree. If this last value represents my remainder, and then if you backtrack, 27 is a constant, negative 12 is going to be x to the first, that makes 1 x to the second. Another thought, it was x to the third originally, yes. When you divide by x to the first, that's going to make it x to the second. Here's the deal, guys. Your answer will always start 1 degree lower than your original problem. So since my original problem was x cubed, my answer starts x squared. So 1x squared minus 12x plus 27. Did I get your question in there somewhere, Landon?
Yep.
So some success there?
Yep, I did. So we don't make that 2 negative in the beginning.
No. The number you're putting in the box to divide by is always going to be, since it's coming from a linear binomial there, it's always going to be opposite the sign in there.
Oh.
Okay? Yes.
Okay.
So you get 2 times 1, and then the answer, negative 14 plus 2, you do 2 times that, then you answer that, then you do 2 times the answer to that.
Yes.
Okay.
Yes.
Okay. Okay, so let's set up C. I have several practice examples, and we're going to go down here in the bottom half of the second half of the lesson and talk about how we can use synthetic division. Okay. Example C, what goes in my box?
3, positive 3.
Since it's x minus 3, we're going to put in a positive 3. What numbers go next to the positive 3?
2 negative 7.
Did you guys hear what CJ said? 2, negative 7, 0, negative 4. Why do we have to put a 0 in there?
Oh, because there's an x to the 1.
Okay. Are all of my terms in my original problem? It goes x cubed, x squared, and then it goes
Are you kidding me?
number. We are missing an x term. We are missing a 0x to the first. Guys, this is synthetic division. There is no saving yourself if you don't put that 0 in. I hate to tell you that. There is no saving yourself. Your answer will be wrong. So you have to get that 0 in there. Now, the rest of this, normal synthetic division. So we're going to drop the 2. And then we're going to multiply. 3 times 2 is 6. Then we're going to add. Negative 7 plus 6,
No.
negative 1. Then I'm going to multiply. 3 times negative 1, negative 3. Then I'm going to add 0 plus negative 3, negative 3. Then I'm going to multiply. 3 times negative 3, negative 9. And then I'm going to add negative 4 plus negative 9. Negative 13. Okay. How's my answer start here?
2x.
2x squared. Got it. Because my original problem was x to the third, we're going to go 1 power less than that, so x squared. So 2x squared minus 1x minus 3
Negative 15 over x.
minus 13 over that divisor of x minus 3.
Oh, I did not. Come on,
I just don't get. Oh my goodness. Careless mistakes.
Okay.
I didn't. I forgot.
Are we good here? Gentlemen, you've answered your questions, right?
I got it.
Okay.
We are good and ready.
If you're not catching on, if there's something that's not making sense, please ask. Some of you are waiting for the remainder theorem, I know. So, okay, D, did you guys do D?
I did.
Landon did, but I think
I got
What goes in the box on D?
positive 1.
1.
Opposite the number, right? If it's x minus 1, I remember it like that. We're going to use x equals 1. What's my row of numbers that go next to my 1?
3, and then you're not tricking me, all right? 0,
You tricked me.
negative 5, 10.
Okay. You guys got that?
Yeah.
3, 0, negative 5, 10. And it's a 0 because
Because you got x.
I've got a 0x squared I've got to pretend is there. Okay. Process is good now.
Bring your 3 down.
Bring the 3. 1 times 3 is 3. That goes under my 0. 0 plus 3,
3.
3. Multiply again. 1 times 3,
3.
3. That bounces under my negative 5. Add negative 5 plus 3,
2.
negative 2. Multiply. 1 times negative 2, negative 2. Add 10 plus negative 2, 8. And that, of course, means 8 is my
Remainder.
remainder. Okay. What's that first 3
X
represent?
squared. 3x squared.
3x to the second. It's 1 power less. Plus 3x minus 2.
That should be plus 8 over x.
Okay. Plus 8 over x minus 1.
Yeah.
It's a positive remainder, so we get to say plus that fraction. And it is 8 over the divisor x minus 1. Okay. Yes?
The final answer, the first x value is there's 1 less than the
Always. She said that.
Yes.
I gotta make sure.
Okay. Synthetic division. Now, we're going to talk about a couple quick ways we can use this. So one thing we're going to talk about is the remainder theorem. Now, officially, if a polynomial, p of x, is divided by a linear divisor, x minus a, which is what we just did, then the remainder is p of a. And so what that's saying is whatever value is right there, if you were to just plug it into the polynomial, you're going to find that remainder. So I'm going to talk briefly. Remainders have a lot of different uses when we talk about dividing polynomials and stuff. And so we're going to talk briefly about 2 different ways to find remainders. How you find remainders is going to be up to you. I know I have my preference, but that's my preference. Okay? You have to do you. So example A, for this given polynomial, and notice what it says, a C value of -2. Find P of C. So this is saying find the remainder, and they want us to do this 2 different ways. A, by direct substitution, and B, by the remainder theorem, which when it says by the remainder theorem, I really should have said then synthetic division. Okay. So I'm going to show you 2 different ways to get the same answer. Okay. When they talk about finding P of C by direct substitution, what is our C value? -2. So they're saying find P of -2. In order to find P of -2, what does that mean? We take the -2 and put it where? Every place we see an x, right?
Yes.
So since it says x cubed, I'm going to say -2 cubed plus 8x squared is 8 times -2 squared plus 12x is 12 times -2 plus 5. This is one way to find your remainder. What is -2 to the third? -8. -2 to the second is going to be a +4 times 8 is going to make this 32. 12 times -2 minus 24 plus 5. Calculator can do the math for you. You can do it. -8 plus 32 is 24. Minus 24 is 0. Plus 5 is 5. We just found P of -2 to be 5. Folks, we just found the remainder. Okay? We just found the remainder. Now, maybe you like that way. Maybe you didn't like that way. What's option B? Option B is to use the remainder theorem. Remainder theorem, though, indicates more along the lines of synthetic division. So, let's set this up for synthetic division. Now, when you set up synthetic division, what were we dividing by?
-2.
Okay, now here's the catch, or here's the deal. It said C equals -2, yes? What's going to go in here?
Oh, 2.
-2.
Oh,
No.
Oh my God.
You keep, this is the catch you have to watch out for. If they tell you to use this value, in this case -2, don't change the sign, use that value. Because this is representing x minus -2, which in other words is x plus 2. And if I told you x plus 2, what would you know to do?
-2.
You would change the sign. If they don't give it to you in that binomial form, you keep the sign you're already at. So we're going to use -2. What are my coefficients that go here? 1, 8, 12, and 5. Okay. Practice this synthetic division with me again. Drop the 1. -2 times 1. -2. 8 plus -2. 6. -2 times 6. -12. 12 plus negative 12? 0. Negative 2 times 0?
Plus
0. 5 plus 0? 5.
I think I'd rather do
What is that?
the remainder.
That's the remainder.
5 is my remainder. So, when it asks you to find P of C or P of negative 2, they're asking you to find the remainder. Now, I think there's 1 or 2 problems in homework where they say do it both ways. But most of the time, they just say do it. So, you pick. Do you want to sub the values in? Do you want to do synthetic division? And here's the deal with the synthetic division. The only answer I care about is 5, the remainder.
Is it the same thing now? Oh.
Now, okay. I changed the wording on B, although it's essentially the same question. For the given polynomial and the given C value, use the remainder theorem to find P of C. You pick. What do you want to do? Now, what is my C value, by the way?
Is it
It's the negative 5.
It's a negative 5. And I put it that way because homework sets it up like that some, so I didn't want you guys to be like, wait, where is my C value? So we're trying to find P of negative 5. What are my options? I could do P of negative 5 and plug it in, or I can set negative 5 up for synthetic division. You have your preference? Which one should I go?
The right. The right is much easier.
Good. I'm trying not to persuade you guys one way or the other, but I prefer synthetic division. The math was easier there, wasn't it? I didn't have to pick up my calculator to do synthetic division. I might have to pick up my calculator over here. Now, if you prefer that one, though, you can use that one. Yeah. Okay, you can do negative 5 to the third plus 10 times negative 5 squared plus 29 times negative 5 plus 24. Or you can just synthetic division. What are my numbers? One, 10, 29, 24. Drop the 1. Negative 5 times 1 is
5.
negative 5. 10 plus negative 5 is 5. Negative 5 times 5? Negative 25. 29 plus negative 25? 4. Negative 5 times 4? Negative 20. 24 plus negative 20? 4. What is P of negative 5? Or in other words, what is my remainder? 4.
That's your answer.
That's your answer. If I would have done this, it would have been negative 125 plus 250 minus 145 plus 24. And you would have also gotten the 4. Okay, so that's one use of synthetic division. We can use it to find remainders. And there is time where it's helpful to know what is the remainder, is there a remainder? Okay, 2 other practices on the back. The back talks more about the factor theorem. So when we talk about synthetic division, we have the remainder theorem, which basically says you use synthetic division to find a remainder. And we have the factor theorem. The factor theorem says I can use this to determine if this is a factor or to even find factors. And that's what we're going to talk about here. So, factor theorem says the binomial x minus a is a factor of p of x if and only if p of a equals 0. What is that saying? What's p of a represent? The remainder. So that's fancy talk for saying if and only if the remainder is 0. So, we're going to look at example A, and the idea is we're going to use synthetic division to factor this if it factors. So, what number did you guys put in the box?
Yeah.
I mean, you got 50-50 shot here, right?
Wait,
4 or negative 4?
It's positive 4 because it's an x.
Okay. Because this is x minus 4 equal, we can set that equal to 0, and I am going to use positive 4. Coefficients? Do I need any zeros here? No. Does it hurt to check? It's a good idea to check, right? Okay, so let's see what our synthetic division tells us. Bring down the 1. 4 times 1 is 4. Negative 10 plus 4? Negative 6. 4 times negative 6? Negative 24. 28 plus negative 24 is 4. 4 times 4 is 16. And negative 16 plus 16 is 0. Okay. What does that 0 tell me? Okay. That 0 is my remainder. And because this remainder is a 0, that means x minus 4 is a factor. Your first question in homework might be, is this a factor? To answer whether or not it's a factor, if you get a remainder of 0, yes, it's a factor. If you get a remainder of anything else, no, it's not a factor. Okay? Easy enough yes-no question there? Now, I was supposed to say it, well, I want to write this in factored form. Okay? P of x was given right there, yes? That's not something that can factor into a nice little product and sum type thing, is it? I can't just say, oh, it's x and x, multiply, you know. So this is where synthetic division can be used to factor. What were we given originally? X minus 4. So x minus 4 is one of our factors. And that's what I put right here. That means x minus 4 is a factor. What's my other factor?
X plus 4.
What do the 1, negative 6, and 4 represent? 1x, what power? Squared minus 6x plus 4. This right here is factored form. I believe there might be 1 or 2 in homework where you're asked to write something in factored form. That is factored form because we put it in 2 factors, the x minus 4 and the x squared minus 6x plus 4. One last one. We want to factor b. What goes in my in my box? Okay, since it says x plus 5, we're going to use x equals negative 5. Do I need any zeros?
Nope.
Okay, he says no. Drop the 2. Am I safe to assume everyone's caught on to synthetic division at this point? Okay, you kind of seem bored with it actually, which there's good and bad to that, right? Okay, multiply. Negative 5 times 2, negative 10. Tell me the number. 9 plus negative 10?
1. No, negative 1. My bad.
Okay. Multiply. Negative 5 times negative 1?
1, 5.
5. Add. Negative 2 plus 5?
3.
3. There we go. Multiply. Negative 5 times 3?
Negative 15.
Add. 6 plus negative 15?
Negative 9.
Negative 9. Negative 5 times negative 9.
45.
Negative 40 plus 45.
5.
What do I know about this problem?
5's your remainder.
Just not a factor.
Okay. So, because my remainder is 5, or actually what I should say, it is not 0, then x plus 5 is not a factor. And if it's not a factor, can I write it in factored form?
Nope.
No.
Oh man.
Okay, guys. 10 or 12 questions, maybe 12.
Lightweight.
Due tomorrow. Lesson 3.4, part 2, in Savas. Okay? Get it done for tomorrow. About half of you need to get the long division done, too.
Me.
Okay?
Can I use synthetic on that?
Thank you.
I would prefer